Welcome to an exploration of SQL versus NoSQL databases. In this session, we will delve into understanding the differences and use cases for each type of database system. SQL stands for Structured Query Language. It is used in relational database systems. These systems organize data into tables with rows and columns, and they strictly adhere to what are known as the ACID properties. A fixed schema design is the foundation of SQL databases, dictating the structure of data storage. NoSQL, which stands for not only SQL, represents non-relational database systems. These databases offer a schema-less design, granting flexibility in how data is stored. They are built for horizontal scalability, making them ideal for handling large data volumes. Instead of ACID properties, NoSQL databases often prioritize base properties, which stands for basically available, soft state, and eventually consistent. NoSQL databases come in various types, each suited for different use cases. Document stores such as MongoDB, CouchDB, and Firebase store data as documents in formats like JSON. Key-value stores like Redis, DynamoDB, and Ryax store data as simple key-value pairs. Graph databases such as Neo4j, JanusGraph, and Amazon Neptune are designed to store entities as nodes and relationships as edges. Column family stores like Cassandra, HBase, and ScyllaDB organize data into column families. Now let's explore the key differences between SQL and NoSQL databases. SQL databases use tables with rows and columns, while NoSQL databases use documents, key-value pairs, graphs, or columns. SQL databases require a fixed, predefined schema, whereas NoSQL databases offer a dynamic and flexible schema. SQL databases are typically scaled vertically by increasing the power of a single server, but NoSQL databases scale horizontally by adding more servers to the cluster. SQL databases follow ACID properties to ensure data integrity, while NoSQL databases prioritize base properties for better scalability. Let's discuss use cases for SQL and NoSQL databases. SQL databases are well suited for transaction-heavy applications like e-commerce platforms and banking systems. Also, they are useful when there are complex query requirements. They are also used when data integrity is a priority. NoSQL databases excel in big data and real-time applications such as IoT systems and social media platforms. They are also used for the applications where flexible schema is important. Scalability is a key differentiator. SQL databases scale vertically, which means you add more resources like CPU, RAM, and storage to a single server. NoSQL databases scale horizontally. This means you add more servers to distribute the load. Vertical scaling is simpler to implement, but has hardware limitations and can become expensive. Horizontal scaling allows near unlimited scaling potential and better fault tolerance, but can be more complex to implement and may present eventual consistency challenges. In terms of performance, SQL databases excel at complex queries with joins, aggregations, and subqueries, while NoSQL databases are optimized for simple queries and document retrieval. SQL databases are good for consistent transactional writes with constraints, while NoSQL databases are faster for high-volume writes and distributed operations. SQL database performance can degrade with very large data sets, while NoSQL databases are designed to handle large volumes with minimal performance loss. Selecting the right database depends on your needs. Choose SQL when you need complex queries, strong data consistency with ACID transactions, a clear predefined schema, structured data with many relations, and legacy system compatibility. Choose NoSQL when you need high scalability, a flexible schema, the ability to handle unstructured data, prioritize availability over consistency, and geographically distributed applications requiring low latency. Modern applications often use both SQL and NoSQL databases. In summary, SQL databases are characterized by their structured tabular data, ACID compliance, and suitability for complex queries. NoSQL databases, on the other hand, offer flexible schema-less data models, horizontal scalability, and support for multiple data models. There is no one-size-fits-all solution. The choice depends on your specific application requirements. Looking ahead, we see trends towards multi-model databases, hybrid solutions, and cloud-native databases. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.